for graphing a rational function that doesn't have any holes. So we're not worrying about any holes just yet, only the asymptotes and the curves that go between those asymptotes. So it says that we will need to factor the polynomials that you can factor. We'll need to find the domain. Remember, guys, we look at the bottom of the function to determine the domain, right? We're trying to see where would the bottom become 0, and that's where it doesn't exist, right? It says we also need to look for a horizontal asymptote if one exists. So remember, this is what we did on Friday, guys. Here, we look at the original function, and we look at the exponents, right? So for finding the horizontal asymptote, we are going to look at the original. And remember, we have a few acronyms to help us. So we've got BO, bigger on bottom than it is 0, right? Then we have BOTN, which was bigger on top than none. And then we also have EATS DC, which is if the exponents are the same, we divide the coefficients, right? Okay, so this all comes from looking at the original function, okay? It also says we'll find the vertical asymptotes. Well, remember, the vertical asymptotes come from the domain, right? And our domain comes from the bottom of the fraction. So this would also come from the bottom of the factored form of our function. All right. Now your x-intercepts. X-intercepts is where we touch the x-axis, right? Your x-intercepts, you're going to find these in the top of the factored form. So top of factored form will give us the x-intercepts. All right. And then your y-intercept says you do have to do a little bit of solving for this one. For this one, you just replace x with 0 and solve for y. And once you found all those pieces, you just go put them all on the graph, it says. All right? So let's give that a try. All right, so it says we will need to factor it. So I'm going to look at my function. Is there anything we can factor out of the top? So I'm going to leave it as negative 2x. What about in the bottom? Any way we could factor the bottom? Yeah, what does it factor into?
X minus 3 and x plus 3.
Right, very good. This is a difference of squares. Awesome. Okay. So now that it's factored, let's see if we can find some of these things. So domain, remember we said domain comes from the bottom of the fraction. So we're asking ourselves, what would we not want to plug in for x or for these x's because it would give me a 0? Well, what would I not want to plug in for this x because it would give me 0? 3. And in this one, I wouldn't want to plug in negative 3. Okay, so my domain is that x cannot equal positive or negative 3, right? Okay. All right, now my horizontal asymptote. Remember, guys, we said for this, you look at the original function, right? So I'm looking at the original function. Are we bigger on top, bigger on bottom, or are exponents the same? Bigger on bottom. Okay, so bigger on bottom, B-O-B-O, what does that mean my horizontal asymptote is? 0. Very good. So my horizontal asymptote is y equals 0. All right, now our vertical asymptotes come from the domain, right? And we said the domain was the bottom of the fraction. So where do we have vertical asymptotes? Where do we have vertical asymptotes? Remember, that comes from our domain. 3 and negative 3, right? Remember, guys, also you can think of it as if I were to take these factors, set them equal to 0, and solve, that's the two answers I would get, right? 3 and negative 3. All right, so yes, very good. We got 2, 1 at 3, 1 at negative 3. All right, then it says to find the x-intercepts, okay? Well, up here, we said that the x-intercepts come from the top of the factored form, right? All right, so here's our factored form, and here's the top. So just like I just did with the bottom, you just take the top and set it equal to 0 and solve. All right, so how am I going to get x by itself? What do I do? Divide the negative 2, and I'm going to get that x is equal to 0. So that means I have an x-intercept at 0, 0. All right, and then last we have the y-intercept. Well, remember, guys, we said for y-intercept, it told us replace the x with 0 and then solve for y. So in this factored form here, anywhere I see an x, I'm just going to plug in 0 and set it equal to y. So I'm going to have y equals negative 2 times 0 over 0 minus 3 times 0 plus 3. All right, so we're just solving for y. So in the numerator, negative 2 times 0 is just going to give us 0, right? And in the bottom, 0 minus 3 is negative 3. And 0 plus 3 is 3. So we end up getting 0 over negative 9, right? Negative 3 times 3 would be negative 9. But 0 divided by anything is still just 0. Okay. All right, so that means we also have a y-intercept at 0, 0. All right, so now I am just going to go graph all of these things that we wrote down on our blanks. All right, so we said we would have a horizontal asymptote at 0. Okay, so that means horizontal line right here on 0. We said we would have vertical asymptotes at positive 3 and negative 3. So I'm going to draw 1, 2, 3, 4, 5, going both directions. All right, so we said we're going to have vertical asymptotes at positive 3 and also over here at negative 3. All right. And then we also said that we were going to have an x and y intercept at 0, 0. So I've got this point right here. Okay. Now, as far as the curves go, we may or may not know where they fall. If that happens to you, just pick an x, plug it in, and see what you get for y. So I don't know what's going to happen between here and this vertical asymptote, right? But we've got x values 1 and 2. So I'm going to pick 1 or 2 and go plug it in and see what we get. So let's say I pick 1. Okay, I'm going to go plug 1 into this factored form right here. So if I plug in 1, then I'm going to have negative 2 times 1 over 1 minus 3 times 1 plus 3, right? Well, negative 2 times 1 is negative 2 over 1 minus 3 is negative 2. 1 plus 3 is 4. And what's negative 4 times 2? Or sorry, negative 2 times 4? Negative 8. Okay, and then negative 2 over negative 8 will simplify to a fourth. So we have a point at 1 and a fourth. So somewhere up, right? Something like this. All right, so it would appear then that this part of the graph is going to go up, right? Okay, but maybe I don't know if this side is going to go up too or if this side is going to go down. then I would pick, again, some value that falls in between here and plug it in. So let's plug in -1. So I'd have -2 times -1 over -1 minus 3, -1 plus 3. So that's going to give me 2 over -4 times -2. Oh, wait. -4 times +2. Sorry about that. Which would give me -8, right? So this one would simplify to -4. So that means this one actually is going down, right? So this side looks something like this. All right, so when you have sections like this, guys, on the outside sections, there should usually be one piece here in this curve, right? And one piece in this curve, or vice versa. One here and one down here. So if you are unsure of where it is belonging, just pick a number, plug it in. So something past 3, like let's say we plug in 4. So if I were to plug in 4, that'd be -2 times 4 over 4 minus 3 and 4 plus 3. So that'd be -8 over, this is 1 and 7. Well, -8 over 7, that tells us it's down, right? So that means in this section over here, I've got a curve that looks something like this. The other curve, guys, should always be opposite. So if this one is down here, then this one should be up here, okay? So we'll know that we have a curve that looks kind of like that, but up here. So for those, you shouldn't have to do both points. Wherever one is, the other one's in the opposite spot. Okay, let's do another one. Let's flip it over on the back. All right, so it says we need to factor it because we find different things depending on the way the function is written. So, is there any GCF in the top? Anything to factor out first? No. Okay, so we'll go ahead and try and factor it. So remember, the first term here, guys, comes from the first term of this function. So that would have to be 2x and x that would multiply to give us 2x squared, right? Okay? And then what multiplies to give us -6? 3 and 2. Okay, we just need to make sure we put them in the right spot. So inside, 3 times x would be 3x. And outside, 2x times 2 would be 4. Can we make 3 and 4 give us -1? Yeah, we would want the 4 to be negative and the 3 to be positive, right? Okay. Over in the bottom, this is a difference of squares, right? Just kind of flipped around. So, remember this term tells us what to put first, right? What multiplies to give us 9? 3 and 3. And then this term tells us what to put next. So what would multiply to give us -x squared? -x and +x. Very good. Oops. There we go. All right. So domain. Remember, domain comes from the bottom, guys. What number would I not want to plug in here? 3. And what number would I not want to plug in here? -3. So my domain, we're saying cannot exist at positive or -3, right? Okay? All right, then for the horizontal asymptote, remember we look at the original, bigger on top, bigger on bottom, or exponents the same. What do we got? Exponents are the same. So that's eats DC. What do I do? Coefficients. Okay, so that'd be this piece and this piece, right? So it looks like the coefficient in the top is 2 over the coefficient in the bottom would be -1. So 2 divided by -1 tells us it's at -2. Okay? All right, vertical. Remember, vertical asymptotes, guys, those are like our domain. They come from the bottom, right? So where are we going to have vertical asymptotes? Positive and negative 3. Very good. So at x equals positive and negative 3. All right. Then for x-intercepts, remember we said these come from the top, right? So you take the top and set it equal to 0. So I got to set two things equal to 0 this time, right? Because we got two pieces in the top. All right, so I need to solve. What am I going to do first? Good. Nice. So that's going to give us negative 3 over 2. All right, so we got a 0 at negative 3 halves, 0. What do I do for the other one? Just add 2. So we end up with another one at 2, 0, right? Okay. Then the last thing we're supposed to find is the y-intercept. Remember, guys, they said take 0 and plug it in for x to find the y-intercept. So that's going to be y equals, in that first parenthesis, we'd have 2 times 0 plus 3 times 0 minus 2 over 3 minus 0, 3 plus 0, right? Okay, so in this first parentheses, we multiply. 2 times 0 is going to give us, and 0 plus 3 would be 3, right? Second parentheses, 0 minus 2 would be negative 2. And then in the bottom, 3 minus 0 is 3. 3 plus 0, also 3. So we got 3 times negative 2, which would be negative 6, over 3 times 3, which is 9. All right. Now, negative 6 over 9 will simplify a little bit. What would that simplify down to? Nice. So we have a y-intercept at 0, negative 2/3. Okay. So let's go and graph what we know. Okay, so first we had a horizontal asymptote at negative 2. So at negative 1, 2. Down here I've got a horizontal asymptote. Okay. We also have vertical asymptotes at positive and negative 3. All right. And then we also found that we had zeros at negative 3 halves 0. Remember, negative 3 and a half is like negative 1.5, right? So at negative 1.5 and at positive 2. All right. Now, again, we may not be sure what's going on in between, right? Something I also sometimes do, guys, is I'll make a little number line so that I can keep track of where I'm plugging things in. So like we said, we knew there's a point at negative 3 halves, right? We know that there is a point at 2. And then we've got our vertical asymptotes at 3 and negative 3. We just need to figure out, are we above or below the line in all those other spots, right? Okay, so let's see. Let's say we're checking for the middle first. So I need to pick something in between negative 3 halves and 2. And I'd pick the nicest number. So maybe 0. Plug in 0, see what we get. Okay, so let's plug in 0. If I were to plug in 0, 2 times 0 would give me 0, right? So really just 3. times -2 if I plug it in the top one. So 3 times -2 is going to give me -6. So we've got -6 over 3 minus 0 would be 3. 3 plus 0 would be 3, right? Well, we already did this. We said we're going to end up getting -6 over 9 or -2/3, right? We already found that one, so that's nice. So we know that in here, we're negative, right? So that means that in between here, we can go ahead and draw it with that y-intercept at -2/3. So here, we know it looks something like this, right? In between there, it goes below the line. Okay. Now I need to pick something that's between here and here and here and here, right? So maybe we pick something like, what's in between on there? Let's do -1, -2 would be bigger than -3/2. Okay, so -2. If I plug in -2, I'd have 2 times -2 plus 3, and then -2 minus 2 over 3 minus 0, 3 minus 2, and 3 plus -2. So minus -2 here would become a plus. All right, so in the top, 2 times -2 is -4. -4 times 3 is -12, right? -2 minus 2 is -4. -12, -4, that becomes a positive, right? A negative times a negative is a positive. And then down here, we also have positives, right? So a positive over a positive tells us we are going to get a positive value. So in between here, we got a positive. Well, it should follow a pattern, guys. So that means that over here should also be positive, right? They should match. So that means on my graph, I should be able to draw something, make it thinner. Something going up because we said it's positive here and here because it's like a parabola, right? One side has to match the other. All right. Now this one is kind of weird because it has a parabola in the middle, then that means that the other two pieces probably aren't opposites of one another, right? But it should follow a pattern. So if it's negative here and positive here, then when you go past those points, it should be negative on the ends as well. So it should go from positive, negative, positive, negative, positive. It should alternate down your number line, okay? If you're unsure, you can always pick a number to plug in. I could pick something bigger than 3, like 4. I could plug it in. I'd have 2 times 4 plus 3 times 4 minus 2 over 3 plus 4 times 3 minus 4. Well, in the top, this is all positive, right? That's only going to give me positives in the top. In the bottom, this is positive, but this is negative, right? Well, in a fraction, a positive over a negative is going to give me a negative. So just like we said, it follows a pattern, right? So if it's negative here, it's negative here. So that means I should have curves in this section, like this, and in this section, like this. All right, so I know we know how to find all of these things. The only thing that can be tricky is knowing where to plot your curves. So if you are in complete doubt, just plug in a number and it'll tell you where it falls, okay?